All right, so the last problem on homework 4.6 I thought was one of the more challenging ones. We've got the volume of the sphere, like the last question in the lesson. And remember, we have to pay attention to whether it's feet or square feet versus meters or square meters or feet per second or miles per hour. So anytime we have an applied problem, we got to make sure we have the right measurement units. So here, we're asked, units must be consistent. It says R is the radius in the formula, V is the volume. And if the units for the radius are kilometers, what are the units for the volume? Well, since we're cubing the radius right here, that means we would be cubing a kilometer. So we would have this giant cubic kilometer. So just imagine this huge box that's 1 kilometer wide, 1 kilometer long, and 1 kilometer high. So the cubic kilometers would be the appropriate answer there. So just think about that, what a cubic kilometer is. So just imagine a box where that distance right there is 1 kilometer. And then I'm going to head that way 1 kilometer. And then I'm going to head from this corner straight up 1 kilometer. And I'm making a box, which is a cube. Which, to the best of my artistic ability, here's my cube. Okay, so this right here is a cubic kilometer. A kilometer is a little bigger than I'm drawing it here, right? It is what, 60% of a mile. And then we're actually playing around with a cube, a sphere, excuse me, and the volume of a sphere is 4/3 times pi times the radius to the 3rd power. And if the radius is kilometers, the volume would be cubic kilometers. Okay, so that means we're gonna have to pay attention to units later. Next thing is, how would we go about solving for R, and what would the result look like? Which one of these versions here? So let's play around in the notebook. So in this right here, I'm gonna rewrite it as V equals, V for volume, 4/3 times pi times the radius cubed. Now we just solved an equation like this, but we had a number for V, that was that 48 cubic inches, but now we're just gonna leave it as a V. If I had a cube on one side, when I solve on the other side, there's gonna be a cube root. So I can kind of rule out a couple of answers here. Anything that has a cube in it is going to be incorrect because the cube belongs to the R, not the other side. So it's one of the answers with the cube root. I just have to figure out which one. So we're going to actually solve it to figure it out. So earlier when I solved this, my recommendation was to get rid of the 4/3, was to multiply by 3/4. And I have to do that on both sides. Oops, if I could only write that correctly. Not 3/3, 3/4. And the point of doing that there is that 3 divided by 3 is 1, essentially canceling, and 4 divided by 4 is 1. So it cleans up dramatically this side because 1 times pi is just pi, and pi is also multiplied by the r cubed. So the right side cleans up nice. On the other side, I just have 3 over 4 times v, which I could just leave it like that. Excuse me. Next thing I have to do is get rid of the pi. Well, the pi is multiplied, so we should divide to get rid of it. So I'm going to divide, oops, that again, there we go, divide by pi. And over here, it doesn't matter where I divide the pi, so I'm just going to throw it right there. That would be okay. Point of this is that pi divided by pi is 1. 1 times r cubed is r cubed. And on the other side, I have 3/4 times v over pi, which could also be written as 3v over 4 pi. So either way is okay. They're identical. Last step would be to get rid of the cube by taking a cube root. So then I will end up with the cube root of that whole crazy fraction. And when I write it on paper, I want to make sure it's clear that every single thing is inside the root here. So try to be as neat as you can. So you need a tall root. And when I exchange a cube root for a cube, I get that variable is now solved for. So r is all by itself here. So again, essentially what I did is I took the cube root of each side here, and a cube root and a cube cancel, leaving just the r behind. So which answer looks best? It is the one that has the cube root and the 3/4. V is in the top, pi is in the bottom. So they're going to be maybe in a different order on your version, but it's the one with the cube root, the 3/4, and the v over pi all inside the cube root. All right, so then we're given some information about the sun and the earth, and we have to play around with it. So let's see, next we have the sun has a radius of about 695,000 kilometers. What is the volume of the sun? Write it in scientific notation. So we're starting off with kilometers as a radius. And earlier we decided that if the radius was in kilometers, then the volume should be in cubic kilometers. And notice down here, they have the answer as kilometers raised to the third, cubic kilometers. And then in scientific notation, using 3 decimal places in the mantissa is just the number that's before the power of 10. So like in the Earth problem below, 1.1 is called the mantissa of the scientific notation. So we just need to plug 695,000 into our volume formula to figure out what the volume of the sun is given its radius. All right, let's do it. So we have the sun, and the radius is 695,000 kilometers. We want to know the volume, which is always 4 divided by 3 times pi times the radius cubed. And we want to cube that number right there. And usually I don't plug in the units, I just plug in the number. So on my calculator, I would have 4 divided by 3 times pi times parentheses 695,000 raised to the third power. So try that on your calculator. And that's going to be a big number, I imagine. Let's try Desmos. So 4 over 3, get out of the denominator, times pi, times that 695,000 raised to the third power. I think I typed it right. 4/3 pi r 695,000. Yep, that looks right. All right, I am getting 1.40618 blah, blah, blah times 10 to the 18th. Anyone else getting anything near that? Uh-oh, my headset might be dying. Can you still hear me, hopefully? Just beeped at me. Let me know if my voice goes out. Okay, so Larissa gave me a yes on that. So I think we were asked for what, 3 decimal places in the mantissa. Oops. And I might have to switch mics in a sec. 1.406 times 10 to the 18th. Would be that there. Okay, I'm gonna have to switch mics. Give me a sec. All right, do I still have volume? Can anyone hear me? Hello, can anyone hear me? Can I get a confirmation?
Yeah.
Yes, okay. All right, so moving on. What is the volume? Oh, this time they give us the volume of Earth, and we have to figure out what the radius is. So we're going to use that other formula that we calculated here to the nearest tenth of a kilometer. Assume the Earth is a perfect sphere. Okay. So, new page, 1.1 times 10 to the 12th. So I'm going to put this over to the side here. So we have Earth. And this time we're given the volume is 1.1 times 10 to the power 12 kilometers cubed. And we need to figure out the radius. And earlier we determined that the radius was equal to the cube root of that crazy fraction, which was 4v over 3 pi. No, that's wrong. It's 3v over 4 pi. And just go back to the notes to confirm. Yeah, 3v over 4 pi, and that's inside the cube root. So what we have to do is plug into that carefully on whatever calculator you're using. And again, in this case, we're replacing v with this scientific notation number there. And usually when we plug in complicated things, it's a good idea to use parentheses. So on my calculator, I'll use the Desmos one because it's slightly easier. I would have the cube roots, and then I would start a fraction. In the top would be 3 times parentheses 1.1 times 10 to the 12th, close the parentheses, divide by 4 times pi. And all that has to be inside the root. So give it a shot on your calculator. Let's see if we can agree on this. And when you get a number, feel free to drop it into the chat so we can see if we agree. All right, I'm getting around 64,000, and this should be kilometers because we started in cubic kilometers. And that looks like I typed it correctly. Anyone else gets around 64,000? And they wanted to the nearest tenth of a kilometer is my recollection. One decimal place. Nope. Nearest tenth of a kilometer. There we go. So I think it would be then 6,403.8 would be the nearest tenth of a kilometer. So make sure you know how to use your calculator to make that happen. You're not just relying on my answer because you're going to need to do this on your own later. Questions on that value? All right, assuming there's no questions, moving on. The sun's radius is blank times the Earth's radius. Okay, so anytime we do a comparison where it's a multiplication, it's a division that gets us there. So if I translate that, new page, actually I could fit it in that page. Just clean this up a little.
So I'm just going to use S for sun. They said the sun's radius is equals blank times, so I'm going to go question mark times the Earth's radius. So I just took their sentence, I translated it into a little math here. To figure out what this question mark is, I could divide the e to the other side. So that question mark times would be whatever the sun's radius is divided by the Earth's radius. So we were given that the sun had a radius of 695,000 kilometers. We just calculated that the Earth has a radius of about 6,000, was it 403.8 kilometers? Let's double check the calculator on that. 6403.8, yep. And so what we have to do is divide those two numbers to figure out what the multiple is. Calculator, so 695,000 divided by 6,403.8 kilometers tells me that the sun is, the radius of the sun is about 108 times, 109 times the Earth. How many decimals did we want? I think it was just one. Use one decimal place. So we would say the sun's radius is about 108.5 times the radius of the Earth. The next question is, I think, the more interesting one. That's just the radius, how much times longer it is from the distance from the center of the sun to the edge compared to the distance from the center of the Earth to the edge. The volume is a whole different matter. We're cubing that multiple right there. Okay, so if I cube 100, that's going to give me what? 100,000? No, like 1,000,000 times, I think. 100 times 100 times 100. Let's check. So in this case, instead of dividing the sun's radius by the Earth's radius, we're going to divide the sun's volume by the Earth's volume. Notice they're in the same order. So that calculation is for volume. So this was radius. Now we're doing volume. And again, they said the sun's volume equals what times the Earth's volume. So that means take the sun's volume, divide by the Earth's volume to get that multiple. So we have the sun's volume. See, that was in scientific notation. Let's go back and get that. That was the 1.406 times 10 to the 18th. And then the Earth's, we also, I think we had that in scientific notation. So here was the Earth's volume up there. That was 1.1 times 10 to the 12th. And what's important here is when we plug this into our calculator, since the numerator and denominator are complicated, you might need parentheses. In Desmos, you don't, because it has a stacked fraction like this. But my Google calculator would need parentheses. So sun was 1.406. And I better start my fraction right away in case it gets confused. Oh, it already got confused. So let's do the fraction. Oh gosh, I'm in the wrong spot. Help. There we go. Fraction. I cannot hit the right buttons today. Fraction. There we go. 1.406 times 10 raised to the 18th was the volume of the sun. The Earth was given to us at 1.1 times 10 raised to the 12th. And are those the same kind of units? Let's double check. We were warned, we had to have our units right. The sun is in cubic kilometers and the Earth is in cubic kilometers. Okay, we're good. So we just need to divide those two numbers and we get how many decimals? 1, 2, 3, 4, 5, 6. Yeah, it's over 1,000,000 times greater in volume, even though the radius is only about 100 times greater. Interesting, huh? cubing things makes a big difference. So what did the answer supposed to look like? Just enter the number. And I'm just going to go to the nearest whole number, should be sufficient. So 1,278,182. No, I didn't say that right, did I? I did, okay. So 1,278,182. Check. 1,278,182 when I round it. Okay, hopefully we did good work. Any questions on any of those values? And we did well.